When a planet orbits a star, the star actually moves as well. They are both actually orbiting around a common center of mass point. We never really talked about that when we talked about the motion of the planets around the Sun, but the Sun does actually wobble due to the gravitational effects of the other planets. This wobble is not very noticeable, but it can be measured. This is one of the principal ways that astronomers have been able to detect planets orbiting other stars in our Milky Way galaxy. We're going to look at this, and the main concept that we're being used here is the Doppler effect, because as the star is wobbling, or basically traveling in its very small circular orbit, we're going to see the Doppler effect of the light coming from that star. As it moves away from us, we will see it red shifted. As it comes towards us, we will see it blue shifted. We're going to allow this simulation to run, and as it stops at certain points, we're able to click on the shifted Doppler spectral line, and from the shift of where it's expected, which is right here at this yellow line, we can actually infer what the star's speed is relative to the Earth. If we graph this over a period of time, we can follow it into a complete orbit and determine what the orbital period it is. Also, the speed that the star moves with towards and away from us, the maximum speed, will infer something about the size of the planet as well. Let's allow this to move. Every time it stops, I'm going to click on this shifted spectral line, and that's going to add a data point to our graph here. You can start to see sort of the sinusoidal curve that is forming as the star wobbles back and forth, both going towards us and away from us. And so now we have a completed curve, and from this we can see what is the orbital period of the planet, because it also is the same as the orbital period of the star. So we started here on day 7, and it looks like it takes somewhere around 60 days for the star to go through one complete orbit, which would also be the orbital time of the planet as well. And like I said earlier, we can also infer things about the mass of the planet orbiting the star by looking at the magnitude of these maximum velocities. And that's how many astronomers have found extrasolar planets orbiting around other stars. Of course, this method is most effective when the planet is very massive, because the effect will be more noticeable. Also, remember that because we can only measure motion towards and away from the Earth, it depends on the orientation of the orbit of the planet relative to the direction of Earth. And also, if we are only seeing, if it might be tilted relative to us, we might not be seeing the full effect. And so we only have sort of a range of estimates of what's going on.